Okay, guys. So Ben, you said you had some problems?
Yeah, something like problem 47.
47?
Yes, ma'am.
Is this section 13.1?
13.1, yeah.
Okay. So something like this one?
Yeah.
Okay. So they want us to find the area bounded by the graphs of the indicated equations over the given intervals when stated. Compute answers to 3 decimal places. The hint says area is always a positive quantity. So in 47, first thing I'm going to do is graph it. Now remember, y equals 12, or y equations, just y equals a constant, is a horizontal line. So with it being 12, my window only goes up to 10. I'm going to have to modify that window. So let me put in the first one at negative 2x plus 8, and then I'll put in 12. They're wanting it to go from negative 1 to 2. So let me go to my window first, and I'm going to make this, say 13, in order for me to see my other line. There's my first one, and there's my second one. Now, if I do a very quick graph of this, my first one's coming down this way. Ugh. And then the other one's coming in up here. So this one is y equals 12, and this one was y equal at negative 2x plus 8. Negative 1, 2, I'll say is about in here. So now if I'm looking for an enclosed region, these are all boundary lines. Oh, let me get that out of the way. So I've got a boundary line here, a boundary line here, at negative 1 and at 2. So what's enclosed is that section right there. Oh boy. So Ben, is that picture all right so far?
Yeah.
Guys, those of you that just came in, we're looking at problem 47 in section 13.1 or page 764. So I've got to do a graph. Now, the next thing I'm going to do, my calculator will move, is doing my interval. I know my lower limit's negative 1, upper limit's 2. Lower limit, another thing you can think or remember that as, is it's the value to the left. So I have written it down. There it is. Now here's the next part. My top curve is the one that's on to the north of the shaded region. So that would be 12. I subtract my lower curve. And it'll come up here in just a second. Well, maybe 15 seconds. But I did 12 minus my lower curve. And since my lower curve is a binomial, I had to put it in parentheses. Almost like magic. So I'm going to clean this up a little bit more. So this is 12 plus 2x minus 8. So I'd have 2x plus 4 dx. Now integrating this, and substituting in my values. But now if I want to check myself, I'm going to go back to my very, very first problem up here. You know, I wouldn't mind this Zoom so much if I could get this IPvo to stay up with me. But I would go here. Let me go to y equals. I'm going to subtract. Because I'm going to go to the curve, whichever one is on top of the shaded region. Let me ask it to graph. Now, if I do second trace for the calc menu, number 7, lower limit is -1, upper limit 2, it should come up eventually to what I have. And notice that the area is positive. It needs to be positive. If you reversed these, your area would come up negative. And that would be an indicator that you've got your curves flip-flop. So that would be a way that you could check yourself. So what you think, Ben?
I think I get it. I think I see what I did.
How about another problem, guys? Anyone?
53.
53?
Yeah.
Same page?
Yes, ma'am.
All right. So I'm going to go graph it. Now in 53, I've got a parabola. I've also got a straight line, and I've got, they want me to go from -1 to 2. .53, let me put in x² + 1, 2x - 2. Go back to my Zoom 6, see if it takes care of it. And the picture will come up here in a bit. So I'm doing a rough sketch. If you'll notice, these two curves do not hit, but they do want me to go from -1. So I'm going to put in that boundary, my lower boundary there. My upper boundary is at 2. Now, do you see the enclosed region? Because this is what you need to shade so you know how to set the problem up. Here's my upper boundary, lower. Maybe I should say my upper curve, lower boundary, right boundary. So it looks like that would be my enclosed region. Is everybody all right there?
Yes.
Your rough sketch doesn't have to be, you know, right on. It just needs to be enough so that you see how to set the problem up. So for 53, I'm going to go from -1 to 2, top curve minus lower curve. Let me move my paper over. And be careful when you subtract your lower curve. If it's more than a monomial, you need parentheses. Clean it up a little bit. So then I'm going from -1 to 2. I'd have x squared minus 2x plus 3 dx. Integrate that. And then do your 2 parentheses. And let's see if we agree. Just integrate it. You don't need to do any substitution yet. Did you end up with, let's see, are we all right so far?
Yes.
When I substituted in 2 and fracked it, I got 14/3 there. Got -13/3. Now to check yourself, go all the way back up to the problem how you initially set it up. Let me go to y equals. I'm going to use my y1 as my first curve, but since it's on top, minus parentheses 2x minus 2. Let me clear that one out. Ask it to graph. So second trace for the calc menu, number 7, lower limit -1, upper limit 2. And that should check with what we had that's under my calculator. Someday, TI might make a calculator that does this up here where you don't have to go back in, but currently they don't have it. So you're going to have to modify it, get it down to one equation so that you can work out the problem. But if you're asked to find, and it says area, then you've got to make sure your area is positive. If anything comes up negative, something's gone wrong. So is there another problem? If that one's all right. You need to find area. Your first job is to go graph. The first job. So, guys, how about it? I'm ready.
Would we be doing anything like number 57 on the same page?
I'm sorry, Derek, I didn't. Can you say again?
Will we be doing any problem similar to number 57 on the same page?
Was that in the homework? I'll tell you.
Probably not. I was just looking at the.
Yeah, it says to 57 odd. We'll look at 57. It says set up a definite integral that represents the area bounded by the graphs of the indicated equations over the given interval. Find the areas to 3 decimal places. Circle of a radius r with a center at the origin has an equation. So this is going to be a half circle, actually. But we need to, since they asked us to find the area, let's go graph it. And if you'll notice, I've got y equals 0. So it's from the curve down to the x-axis. So square root 9 minus x squared. So they're wanting us to go from -3 to 3, which is where it hits. Now, if we tried the U substitution on this, it wouldn't work. So more than likely, what I'd ask you to do is I would like to see the setup. So is that setup okay? Why I wrote it down that way?
Yeah.
Derek said, yeah. How about the rest of you all?
Yeah.
Yep.
Now, I'm not going to go -0 because that is my lower curve down here. But guys, if it's attached to the x-axis, then that's what we did in the prior sections. But if I tried U substitution on this, the big issue is that I'm going to have some stuff left over. So I would want an integral setup like this, and then do the rest of it in your calculator. So the next thing I'm going to do is put an equals there, get my graph back up, second trace, number 7, lower limit -3, upper limit 3. And if it wants it to how far?
3.
I saw 3 somewhere. We'll go 3 decimal places. Oh, there it is. So my answer would be 14.137. You move this up a bit and then you can see the calculator. But Derek, if we tried to do the U substitution on this, I would end up with not only a U, but also an X, and we can't have that. So we can't do it by using that U substitution. The only option we've got is VI calculator.
Okay. That was actually similar to a problem I was having in the a problem in MATLAB. So.
So there was a problem in my MATLAB.
Well, not on 13.1. It was on one of the sections from chapter 12.
Okay. Do you know what the problem was?
It was square root. Yeah, it was similar to that. Square root 81 minus x squared with a upper limit of 9, lower limit of 0.
Oh, upper limit of 9 and lower limit?
Yeah, a lower limit of 0.
Is 0?
Yeah, that was similar to one that, yeah. Mm-hmm.
Okay. Again, we can't use substitution on this. You'd have to use your calculator.
Okay, that answers why I kept getting it wrong.
Well, just look at it just a second. Because if I've got a parentheses raised to a power, I would use my U. So if I come back here,
Yeah, that's where I kept getting stuck.
well, we can't, well, that's the issue. We
Yeah.
can't work a problem as long as I've got U's and X's. So the issue here is I'm going to have to go via calculator.
Yeah.
Was this in 12.5?
Yeah, I think so. It was one of the problems in 12.5, I believe. Again, it was in the math lab, not I didn't see one in the textbook.
Now there's something like 63. It'll come up here in a minute. That might not even, I don't even think that's a section. But on these right here, did it have that symbol where you needed to use your calculator, or it said numerical integration routine?
I don't remember. I'm trying to find that. I'm trying to find the problem right now, but I don't remember it saying that. I don't know. I can't find it.
I'll have to look in. I'll have to look and see. But that if you come up on that situation where you've got a mixture and you cannot cancel out that X variable,
Yeah.
then your only option right now is to use your calculator.
Okay.
Okay, guys. Is there another one? Now, what's happening Wednesday?
It's the 13.1 quiz, right?
Yeah, 13.1 quiz. I think it's due on Thursday. I think it's due on the 23rd.
Oh, is it?
Yeah.
Okay.
But Wednesday, we're having our review. So it might be to your option to maybe, you know, work on that review that's in my math lab. Since your test is going to be in my math lab. And I'll be fielding questions about it. I printed it off, but the questions will vary because my math lab has built into it a routine. It changes values. So my problems might not be similar to yours, but they'll be similar. It might not be the same. There, I'll put it that way.
And I did find that problem. It did say use a numerical integration routine. So that's what stuck me.
I'm sorry. I don't know why they can't say use a calculator. I don't know. But now you know. I'm sorry.
That's okay.
It might come up.
All right.
So how about the rest of you all? Peyton?
The ones I was a little confused about, we went over problems that were really similar, so I think I'll be fine.
Okay. Let me see. Will, you're there, right? Will and Tyler?
Yes.
And I've got Daniel. Reed? Or is Reed here?
Reed is here.
Oh, hey, Reed.
Hello.
How's Reed doing?
I'm doing well. Also, Khan Academy is a great supplement to all of this stuff too, so I've been doing that.
Good deal. Yeah, Khan Academy is good.
Khan Academy has bailed me out more times than I care to admit.
Yeah.
Well, it's nice to have resources. So let me take roll real quick. Please pause recording.